Hello, everybody. Justin here with Redis, and welcome to my weekly stream, Do Birds Dream of JSON, in which I create an application where we can look up, track, learn about, and see information about birds in different locations. Within these locations, you have many sightings. Within a sighting, you'll see at least one bird. And I've basically been wrangling with this really interesting data set and putting it all together. And I think so far it's been pretty fun for me. Hopefully you enjoy yourself watching this as well. So let's actually dive in. So I'm going to be taking a look at Insight just to get everybody abreast of what's going on. So I have a 6.5 gig data set. And I've parsed it into 3 separate categories: sighting, location, and bird. So let's just start really quick with a bird. I have a bird, say the pileated woodpecker. It has a taxonomic order. So this taxonomic order is a unique identifier that is with the data source that I used, which is the eBird online bird site. Basically, it's a huge compendium of all birds. And I'm running it with JSON and search within Redis stack. So I'm using Python, and I'm using Redis Ohm for Python. So that means I've indexed all of these JSON objects. That means it has a primary key. So this is the primary key for Redis Ohm. So, but one thing that you mainly want to keep track of if you're playing at home is that the taxonomic order is a unique numeric identifier for every bird. So we have a sighting. Let's look at a random sighting here. Now, a sighting has more information. It has location. Here's the taxonomic order. So you see it right here as well. And I have other information like who observed it, the time, the date, what were they doing, how long were they sitting there, if there are any comments about what they were doing or how they saw the bird or anything about like the weather or anything like that. It'll be in trip comments or species comments. But the main thing to see here is that we have the taxonomic order and we have locality ID, and those two are connected via a sighting. So let's look at a sighting. This is going to be the third part of this, and a sighting has the locality name. So this, okay, this place is called Noble Knob. I've never heard of Noble Knob. It's in beautiful Pierce County, so that's south of me. And it also has latitude and longitude, which is exciting because if you know Redis, you know that we can actually play with geo-indexing latitude and longitude, and we do a lot of fun stuff with that. Okay, so major item to remember from this is that the locality ID is right here. And this is a unique identifier for every location, and it begins with an L. And basically, a sighting has to have a location and a bird. Okay, so with that knowledge, let's actually switch over to the actual code. Now, what I'm doing here is I'm creating a fast API endpoint to basically serve up information from this database. I chose fast API because I want to learn how to use it, and it's very fast and it's self-documenting, and it's really quite a pleasure to use so far. I haven't had any problems. And I'm also using it for a presentation for a conference that I'll be doing later on this year. So I want to get, just sort of my hands around it and hands on it just to really get comfortable with it. Okay, so I have a couple endpoints here. I want to get just one bird. I want to get all the sightings of one bird. I want to get all the locations of one bird. And this is the one where I'm actually kind of like, oh, I don't know if this is actually like the most efficient as far as we can go with Redis. Now, Redis is an in-memory data store where you can store data in various different data structures. I'm storing everything in JSON, and I have it indexed, and I can search it, and that's fantastic. but I felt while I was coding this out, I felt like I was kind of overlooking the capabilities of Redis. Mainly, I want to be able to store information attached to a location. Say if I want to get all birds that are within one location, I could run a query. I can absolutely do that. But if I just wanted to get maybe the IDs or just the names of birds within a location, kind of like to display on a page, ultimately, I don't really need to iterate through all of those JSON documents that will be returned just to return their names. I don't want to receive 1,462 JSON documents, parse through those just to get names. I want to get just the names. So to do that, I would create a sorted set for every location. So what I'm going to do today is I'm going to kind of walk you through what I've been working on. I'm going to be iterating through all the locations that I have in my database. For every location, I want to go through all of the sightings within that location. For all of those sightings, I want to grab all the birds that were sighted. Ultimately, I want to create a set of those birds in that one location. So that means that I'm going to look up maybe Noble Knob, that random location that I found, and I want to know all the birds that were sighted there, because that's kind of interesting. That means that if you see a bird in one location, the odds are that you're going to see that bird again in that location. That's just kind of how birds are. They're creatures of habit, and they migrate within, a couple 100, 200, 300 miles. So this is interesting information. Also, it's going to stay there and persist. So if I'm looking up a location, I'll be able to look up this sorted set, and I'll always know what birds are there. As I add new birds, if I happen to be at Noble Knob, the location Noble Knob, again, say tomorrow, and I saw a bird, I'll add it to that sorted set with this endpoint. And then I'll maintain that sorted set. And this is just very fast, because when you're retrieving that entire sorted set, remember, sorted sets have two different things within them. It's a set, so it's a collection of unique objects. But with a sorted set, you sort it with a score. And this is sorted by nature. So it's a regular set, only that set is sorted by a given score. Now, I'm kind of cheating because I have a sorted set, and the data I'm going to use as the name of the bird, but the score is going to be the taxonomic order ID of the bird. So I don't care what order it is sorted in, but I'm just going to double up with data being the name and score being the taxon ID. And this is going to help me if I'm going to render this into like a kind of a UI of a list of birds. They're going to have their IDs with them. So enough talk. Let me actually go through with this code. So I am actually starting off. I did one. I'm almost done with this whole concept of, for every location, create a sorted set of birds in that location. So I'm creating a file called create sorted sets. It's just kind of a scratch pad. Make sure it's a little bit bigger. So basically, given a specific location ID, I want to pull all sightings from that location. So simple enough. So this is for my own documentation. So get all sightings from that location. So location sightings is going to be an array of sightings. And then what I want to do is I want to create, I'm going to get all the birds from that sighting. So that will be this little iteration here. Now before I'm creating my sorted set, I'm creating a set right here because you can have a sighting of the same bird multiple times at a location. So if I look out my window and I see an American bald eagle, I'll enter that into my database. If I go there tomorrow, and if I see another bald eagle, I'll enter that into my database. that's fine. I'm creating two sighting objects, but it's the same species of a bird. So there's no reason for me to duplicate a bird entry, if that makes sense. So I'm creating right here a list of unique birds because there's going to be duplicate sightings of the same bird at the same location at different times. Because again, that's how birds work. They have kind of like a territory. So right here, I have unique birds within my list. And then for birds, in location birds. So right here, I'm saying, hey, so for every single bird that I have in my list of unique birds, then I'm going to find the name. This is where I'm going to pick up the name. I'm finding a bird by the taxonomic order because in sightings, I'm adding the taxonomic order to my set. So this set right here is just nothing but bird IDs. Here, I'm taking all those bird IDs and I'm looking up the birds by those bird IDs. Here, and I'm doing a pipeline with this, by the way, because this is a lot of data and it's extremely fast when you're actually running a pipeline on Redis as opposed to not, because a pipeline executes all of the Redis commands without worrying about what you get as a return. So it's just one fell swoop. So right here is where I'm actually creating my sorted set. So let me update my data here. I'm getting the name here. So get names of birds for each taxon. And then here, I am creating a sorted set with score being the taxon ID, which is the bird ID, and the member being the bird's name. All right. So, and then once I've added all of the unique bird names and taxon IDs to that sorted set, then I execute it, and then that concludes all of the unique bird names and their taxon IDs sorted by location. And I ran it with the example location L163354. So that's, again, going to look up that location and then find all the unique birds that have been seen at that location. And I have done that already for one of them. So let me just look up the prefix on Redis Insight and I'll pull it up. There we go. So this is it. This is my sorted set ultimately that I wanted to create. And for this location, and again, notice that I set the key name to include the location ID. So I have three types of information within this sorted set. I have the location ID in the key name. I have the member value. Oh, wait. Sorry. There we go. Not used to switching scenes. I'm in Redis Insight, and I'm looking at the sorted set. You'll notice that I have the key name contains the location ID, so that's L163354. And it has the member values of the bird names, and the score is actually the taxon ID. So these, the numeric value doesn't really mean anything numerically. It is just an ID. These are just IDs of birds, not quantity of birds. And all of these are all unique names of birds that were seen. So this is actually really kind of amazing. Whatever location L163354 is, that's kind of cool. Let's see if we can find it, because I'm just kind of curious. We'll do ft.search. Let's see here. I'm trying to remember bird tracker dot or colon location colon index at locality ID colon. Put this in here. Okay, so your location. I'm just trying to remember key names in my head. It's not the easiest thing in the world. I want to search by the locality ID, and it's called, yeah, locality ID. Okay. That's my string. Let me find some information on my location index. I might have set the locality ID as a tag. Okay, so I did. So I set that as a tag because it's just a one single word, so I don't actually have to do full text on a one single string. So I was right-ish. I just needed to use tag syntax while I was searching. Whew, okay, there we go. So what is this place called? I was just really curious. Oh, Green Lake. Okay, Green Lake is in King County, which is Seattle. So in Seattle, Washington, there's 5 lakes, and Green Lake is a beautiful lake that is full of wildlife. It's also right next to Woodland Park Zoo. So there is a ton of wildlife there. So that's why I'm not surprised that there are so many birds seen. And it's a really great place for just people to hang out and look at birds and walk around the lake and stuff like that. Okay, that makes sense. Thank you for letting me indulge my curiosity there. All right, so let's go back to code. And I just did this for just one location. I want to do this for all locations. And that's going to be a bit of an expensive action, but let's remember that I'm not actually going to be doing this every single time a user submits a new bird or a sighting or location. I'm just going to be doing this like starting up. I'm just going to be doing this once and then providing this to the user for all time. And we'll just be adding single sightings as they add them. Sometimes they'll add a unique birds to this location. Sometimes they won't. So if this looks a bit heavy-handed, it's because it is creating a lot of data, but it's going to be creating it for the long term. So I'm not just going to be doing this one-off per user request. Okay, so I know that I can actually convert one location into a sorted set or create a sorted set from one location. So now what I want to do here, and this is like some driver code, I want to iterate through all of my locations. Okay, so I don't think that that's, I don't think that's too difficult. So what I'm going to do is I'll create an array called all locations, and it's going to be location.find. And I want all. So let's actually don't know if I don't know what happens if I'll just put all. I don't know if that would actually call them all. So I'm going to call location.find all, and I'm just going to print out all locations. And this will just let me know if I actually gathered them all. I could do this in just like a Python REPL, but It takes a little bit of time because I'm also summoning up all the different objects. Okay, so that does work. So now I have 10,000 individual locations. That's really amazing. All right, so this is going to be big. For location in all locations, okay, now I'm going to iterate through every single location, and I'm going to create a sorted set of unique birds from every location. So location dot locality ID. Let me just look real quick in my insight to verify what I'm looking at. Yeah, locality, capital locality ID. Okay, so switch over back here. And there we go. Okay. This is going to be huge. So I think this will work. All right, I just want one little print statement just to let me know that I've actually am running. So right here, I'm printing out the total amount of sightings per location. I think that that's a decent enough value to check out. Okay, so let's see what happens. It's gonna melt my computer. Thankfully, I'm running this locally, so it's not going to be too big. I'm not taking up too much space already. It's only 174 megabytes. This might add a little bit more. So I'm adding, at the bare minimum, 10,000 sorted sets, but I'm not scared. All right. It'll take a little bit of extra time. Oh, there we go. Okay, so we can see these are all unique sightings per 10,000. This is going to take a while. But now would be a good chance to kind of show off some fun. So this is really funny. This is over the weekend. I went snowshoeing up in a location near where I live. It's called Hurricane Ridge. It's in the Olympic National Park, which is on the Olympic Peninsula in Washington State. And I was snowshoeing and I saw this little guy. These are all, this bird was perfectly fine. It just decided to hop on my hand. This is a Canadian jay. So it is from the jay family, and we're really close to the Canadian border. So I'm not surprised that we saw them. But they're very, very friendly. I was just taking a break, taking in the view. You can see the view. And they just decided to just hang out and, try to ask for some food. I didn't feed the birds because you're not supposed to feed birds, but it was really nice. I made a friend, and I told him that I was making an application starring him. And if you liked it, give me 5 stars on the Apple App Store or whatever. But yeah, it was kind of funny. They were very friendly. They kept on following us as we were snowshoeing along. And yeah, this is, by the way, this is the view. Kind of ridiculous, right? It was a lot of fun. It was 22 degrees Fahrenheit. So my beard froze. I had little droplets frozen on there. But yeah, it was a lot of fun. These are all the Olympic Mountains. It's a huge mountain range in Washington State. And yeah, we had a ton of fun. And I stayed warm because I wore, proper clothing. All right, so we are still chooching along. I shouldn't have actually printed this out. I would have gone a lot faster. So I might just interrupt it and call it good, and I'll run this in the background. I don't mind. I don't mind too much. What I would like to do, let's switch over to Insight while we're doing this, because we can actually look. I know that all of the key names for these sorted sets are going to start with location:L. So that's why I'm going to use Redis Insight search function. All right, so we have a bunch. Cool. We have 1,628. You also notice that, look at all these commands per second. It's good to see. But also, we're not really hitting the size too hard, which is great. It really makes me happy. So let's look at these. For this location, there's only, okay, so this is kind of what I expected. This location had only one sighting, and that was of a red-shouldered hawk. Not a red-tailed hawk, a red-shouldered hawk. Big difference. This one right here has a trumpeter swan. Ooh, I didn't know we have swans in Washington. This one has, okay, so this is huge. Canada goose, a mallard, a gull, a cormorant. So I don't know if anybody here knows their birds, but this makes me think that this is near the water, because those are all waterfowl and water birds. Cormorants are really cool. They sound horrible, but they're beautiful. That's kind of how seabirds are. American robin, song sparrow, chestnut-backed chickadee. So this is probably a somewhat urban area next to the water. Let's have some fun and check it out. Why not? While we're waiting for our results to come back. So I'm going to change the locality ID to this locality. Let's find out where it is. All right, so this is, Discovery Park in Seattle. So this is very close. This is an urban area. I think, Well, let me just find out real quick for you. Discovery Park. Definitely been here. Oh, yeah. Okay. This is nice. I have this awesome feature where I can do this now. Discovery Park is, again, on the water of Puget Sound, and this is all Seattle right here. And this is Green Lake, by the way. So we saw that last result. This is Green Lake. This is Discovery Park. So this is why I generally see a ton of seabirds hanging out. And then this is me, approximately. And then Olympic Park, National Park, and Hurricane Ridge was around here. So this is where I was, where I got to hang out with my friend, the Canadian Jay. So, all right, it's enough show and tell. Looks like we're done here, which is awesome. Let me switch over to Insight, and let me refresh this search. And all right, so there's a ton of keys, and I love it. It looks like we got them all. Quail, pigeon, collared dove, hawks, horned owl, woodpecker, right on. So this is actually really cool. So now we can actually get all of these different birds from one location. So now that we've created this, let's actually hook it up to our API. So we can actually serve this as JSON. Okay, so I want to take down really quick this key name, and I want to create an endpoint. So go up, get all the sightings, capture all indications or trips. All right, so this one, location results. I don't think we're creating this. We're finding. Sorry, I want to see if I'm actually replacing this whole code here, which would take a long time for the user to endure. We're looking up all the sightings by a specific bird. We're adding the locations of that specific bird sightings, and we're finding all the locations. Okay, so this is different. This is finding all locations by one bird. And here, I'm going to create app.get locations. This will be locality ID, and then we're going to do birds. So it's kind of the opposite. We're looking for all the locations of one bird up here. Now we're looking at all the birds for one location here. So async def get read location birds, and then I'll add in locality ID. Okay, and then now all I have to do is parse out, or no, oh, you have to do any parsing. I already did the hard work. Retrieve the sorted set of birds from location, and that's all that we have to do. So this does not require Redis OM. So I do believe I have a database instantiated. No, I don't. Okay. The Redis equals, let's do bird.db. No, capital bird.db. There we go. All right, so now I can just call Redis right here. So let's do this. Redis dot z range. So that's the command to get all birds or get something from a sorted set. And then I want to create the key. start, end. So I'm going to have just a key name. Or let's just get location sorted set key. I'm going to create a variable here. So just going through here, key, and then the start is 0, end is -1 because I want to get everything. So you believe with scores is already baked in, so we'll be getting that as a freebie. I don't want any offset, and we'll receive, okay, desk boolean indicating whether to sort the results in reversed order. I don't need them sorted. Indicates to return the scores along with the values. The return type is a list. Okay, so I guess let's just try it without and see if it just does it automatically. Let's trust Redis. Okay, and then I'm going to define this key, which will be location. Oh, I just literally have it right here. Okay. This is going to give me a huge array. I do believe, just as a quick little check for understanding, I'm going to print the length of my location sorted. Location sorted set. And then this is probably going to be big, but I can probably accept query params for offsets and pagination after I get this done. That's not as interesting as it is to actually play with the database. That's who I work for. Okay. I have, all right, so I have Fast API running. Let's just curl from here. Let's see here. What was 127.0.0.1 colon? What was my? I have so many servers running at any given time. Okay, this is it right here. I sometimes forget what everything is. So let's go in here, 8,000. Let's just, let's see here, locations, and then let's look. I'm just going to pull really quickly the locality ID of something that we already know. Let us up for success, and then birds. Okay. Location ID is not defined in line 64 and read location birds. Okay. Location ID, locality ID. Okay, my bad. That's very simple to fix. It's a good problem to have. Right. Okay, cool. So now we have, oh, this is so great. Well, it's not everything that we want, but we have a list of all the birds that we're seeing at that location. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. And then let me look at this real quick. Was that the one I just put in? Oh, yeah. Okay. Okay, I'm happy. So this tells me that, see, I still want to get those bird IDs. So I want to add the extra with scores colon true. I believe I passed this in as, now this kind of gets me. This is, again, I'm exposing my ignorance with Python. JavaScript, it's kind of different. So passing in things as arguments, I'm still kind of new, and I don't care. I'll admit it. We're all friends here. Okay, so this option, no, this is a positional. So that's bool with scores, literal true. false with scores true. Oh, I don't think this matters. I'm just kind of flailing. So just simply take the argument. I'm pretty comfortable with Redis. It's just going back into okay. Oh, maybe it's just that simple. I'm pretty comfortable with Redis. It's just going into Redis Pi. I'm a little iffy. Oh, there we go. Yeah, I was right. Cool. So now we have this lovely collection, this array of tuples. So let's actually let's set this up to be a little bit prettier. Location or locality ID. I'm going to pass it back to them. So locality ID, and then bird set will be our location sorted set. And all right, and then let me actually just run this, and so we can take a look at it from the browser. And let me bring you over to the browser. Ooh, it's a little off. Let me fix that for you. There we go. Cool. So now we have all the birds returned to us. And what I was thinking is that when we're displaying like, a specific location, we can just see a list of birds that we can see. Would also be really neat if we could also include maybe the latitude and longitude eventually. But that's something that we can play with at a later time because we can do an absolute ton of stuff with latitude and longitude. So awesome. We just accomplished a nice little task. What else can we do? I want to kind of like stick to this whole idea of creating sorted sets. So now looking at this, I've created a sorted set of birds within a location. That means that we should consider doing that to birds / bird ID / locations. So I want to look up all the locations where one single bird has been seen. I don't think that we can. I'm thinking out loud as far as whether or not we can reverse the location sorted set. No. I'm just talking out loud. Don't ignore me. So yeah, let's go back to create sorted sets, and I will create kind of basically the absolute reverse of this. But let's tell a story. I like telling a story of how I'm going to do this. So sightings from bird. So taxon ID. So first thing we're going to do is look up. We have to have numbers. Look up all sightings for one bird. All right, makes sense. Where have we seen, or what? Tell me about all the times we've seen this bird. And then let's collect a sorted, or just a set offline, not in the database. Correctly. Collect a set of locations from those sightings. So those sightings are going to be in a list that I can iterate, so it'll be relatively straightforward. What else are we going to do? So once we have that set of locations from those sightings, we can actually make it a little bit more interesting than just a locality ID to display. So just like we're collecting the common names of the birds for every sighting, for every location, let's collect the location names like Noble Knob or Discovery Park or Green Lake. And then let's have their score be the locality ID, which is going to be weird because I'm going to have to truncate that L off, but that's just, I'm willing to take that little parse out. So the score will be the locality ID minus the L, and the member will be the location name. Does that make sense? I think so. Let me say hello to, first of all, let me take a little brain break. First off, Serafel, thank you. Well, thank you. Thank you for joining. Hopefully you enjoy birds as much as we do, or Redis databases, or Redis Home for Python. Any of the thing that we're talking about. Meflik, as always, my buddy, good to see you. Very glad to see you here. Fricko99, nice. Yeah, thank you for joining us. Very casual Monday coding session. So, all right. Oh, let me have some coffee. All right. So let's do this. Once we have a collected set of locations from those sightings, then we need to look up and assemble names of those locations, and then create a sorted set. And the structure will be bird, taxon ID, colon, locations. And then, last but not least, profit. Hey. Okay. So up here, we're getting all the sightings first. So let's do bird sightings. So bird sightings equals sighting.find sighting. Sighting dot taxonomic order is equal to taxon underscore ID dot all. So now look up all sightings for one bird. That's it. Suppose I should move all of these down. What do we do next? Start up a pipeline, create the key name, and create a set for location birds. So we're going to be doing something very similar again here. Kind of feel like it extract this into a kind of like a function that does this to either of those models, but we can do that afterwards. So key name equals bird taxon ID locations, and then location birds now going to be bird, can you guess it? Locations. Okay. So set up all of that overhead. For sighting in location sightings, we're going to pull out the taxonomic order, which is going to be just the IDs. Okay. So for sighting in bird sightings, bird locations. So this is basically deduplicating or just creating nothing but unique locations for that bird. Because again, we definitely have sightings in there within the same location of the same bird of different times. So we don't want to track sightings in this. We really don't care about sightings exactly at this point. All we care about locations where one bird or a species of bird has been seen. So this is creating a unique set. And then once we have that unique set, then we can confidently put this all in a sorted set of locations for a bird. So for location in bird locations, get the names of location for each locality ID. Let's see here. So location object, we're going to look up one location. Let's look for it by location. Locality ID is equal to bird locations is, okay, so equal to that. So basically find all, we're just matching locality IDs here. Get names of location for each locality ID. Create a sorted set with score being locality ID and number being location's name. This is some, I'm glad we're doing this, but this is some funky stuff. I'm almost to the point where I need some diagrams just to like keep track. Text is fine for me, but like I really like diagrams, which I think I'll end up actually doing whenever I push this up. Okay, pipe key name is up here. Bird object is not what I want. I want location object. I don't want common name. I want locality name, I believe. Let me switch over real quick to Insight and let's look at a location. Clear this out. Location, keys. I want just locality. Okay, that's good to know. So I want just locality, and then this will be okay. So we are executing a, well, now we're going to execute. Just looking really quick what I'm for sighting and location sightings. Locations. This actually doesn't, I'm going to return true because this function is actually it's a utility function. It's not really supposed to return anything. This print statement is adequate for me. So I'm going to return true here. And instead of location sightings, I'm just going to do bird sightings. And sightings from bird. And we already did this. Woof. Okay. I don't need to run this. So I'm just going to blank that out. I want to run one bird through this function. And if that one bird works, then we can pretty much assume that it'll work for everything else. So call sightings from bird. And let's pull up a random bird. Bonaparte's gull, 6267. I've learned more like interesting bird names just coding this out with everybody than I have at any other time. All right, 6267. I don't actually think that needs to be a string. Okay, I think this is gonna work. At what point do I need to remove the L? I forgot. Okay. This right here is an L. So I need to subtract, or I need to replace the L with nothing. This is just silly Python tricks, which I can definitely figure out. Methylic. Redis.mycology and Redis.forest should be next topic. Well, I'm in the Pacific Northwest, and so there's nothing but forests and mushrooms and birds and Sasquatch. So I could definitely do that. I have a couple of mushroom hunting friends that could probably help with that. I actually had somebody that I was telling them about this bird app, and they're like, well, this is really cool to actually do this for mushrooms. So yeah, no, you're actually quite onto it. Apparently, like there's some really good websites for documenting information about mushrooms, but nowhere for like setting up sightings and locations. Also, a good mushroom hunter, they don't tell you their locations because sometimes they want to keep them secret because you have like really tasty mushrooms like morels or chanterelles, or, and this is just a rumor I've heard, sometimes they go on the property that they're not exactly allowed to go on, but you haven't heard that from me. Anyways, let's see what happens if I just call this command. Yeah, hopefully nothing will explode. So Python, create sorted sets, YOLO. All right, well, first half of the code is probably working fine. 0. It's because I need to take out the L on that, I believe. Well, let's see. Hold on. Now I'm curious. It should have broken. It should have broke. So bird : taxon ID. Let's see. Bird : star. Let's see if there's anything even created. Yeah. Oh. That as indicating that maybe that's an old, sorry, that's an old key. So this actually wasn't created, I don't believe. Okay, so let's start printing out some debugging statements. So I want to find out bird locations length. So bird locations. My actual cat bird is like hanging out around the house. So she's kind of freaking out, like, why are you talking to me so much? Hi, buddy. You want to join us? Oh, I might get her to say hi. Let me just pop up real quick. Come here, buddy. Oh, here's my bird. An American tuxedo. Okay, you can go. All right. Okay, there's your cat moment. Okay, so I'm just going to figure out what the bird locations are. So this will tell me that something is actually working. Let me also find out if the bird that I have. So I'm going to look up this bird. I'm going to say and find out how many sightings with the location. So these ft.search bird tracker sighting index. Oops. Man, I am always so quick to delete everything. ft.search bird tracker sighting index at taxonomic order because I know that this is a tag. Okay, so they're definitely 419. All right. So we have some results that we should definitely be getting back. So no matter what, this bird's been places. So that's good to know. Let's go back to the code. I'm gonna print out the number of sightings. So number of bird sightings. And okay. And this right now is going to be an L locality ID. So I'm going to look up real quick here. You don't have to see it. How to truncate. Is it replace? Just truncate the first letter from the string. This is some simple Python stuff. Oh, it's okay. That's really, really simple. Stir equals stir. Okay. So we should do 1:. Yeah. And that will actually truncate the first letter off of the front of it. So it won't be the L number. This will just be a unique number. All right, so let's see what happens now. Give myself a little bit more runway to kind of learn about how much code I've just bashed through. Okay. Fun. Okay, so that means that citing taxonomic order equals taxon ID is not working, at the very least. Let me verify. I think that I'm failing to use the correct nomenclature that I've set up for myself. Citing, is it taxonomic order? It is taxonomic order. Okay. So citing.taxonomic order is equal to taxon ID. Does it have to be a string? Maybe it does need to be a string. I set it as a string. All of my little things I've been talking about are all coming to bite me. That I've been saying, oh, I'm going to need to fix this. I need to convert this to a string from an actual integer. Well, I think it's now starting to bite me on the rear end, if you will. So, okay. Convert this to a string, and let's see if it's happy. I don't know if it's going to be that much of a difference, but okay. All right, so this is great to see. So now we have number of bird sightings, 419, bird locations, 1. That's weird. List index out of range. So I think that's my bad. That's me trying to do a shortcut. So let's actually print location. Also, I have a question. I have a query. Why is bird locations set to 1 for sightings in bird sightings? Because I'm adding the exact same bird. So this should not be taxonomic order. This should be locality ID. I copied this from up here, and I didn't switch over the taxonomic order. This needs to be locality ID. That's why this was actually upset, because I was trying to subscript a number instead of a string. All right. Learning. We're learning. Learning is fun. Okay. Whoa. this looks much better, much better. The length of bird sightings is happy. Print location, these are all locations. That's very happy. So let me actually look up an insight that we've done this correctly. The name of it is going to be, again, key name, bird colon, and then taxon ID. So I'm just going to look up bird colon and look at the key that I made. Bird colon star. There we go. So this should be it. Okay, so this I don't know about this. There we go. Okay, I was a little confused there. So bird colon taxon ID of the bird locations. So now this is a huge sorted set of all the locations where this bird has been found. And this score is numerically arbitrary. We don't care about the actual numeric value of this. This is the actual ID of the location. So I have the ID of the location and the location name. So again, this is a goal, I believe. This is a goal. So this makes sense that these are all near water. So Point No Point, absolutely gorgeous, about 30 minutes drive from me. Discovery Park, we saw that in Seattle. Alki Beach is in Seattle. Tokeland, that's over on the actual ocean, which is kind of far from us, actually. Seebeck, Big Beef Harbor, that's actually in the peninsula where I live. Hobuck Beach, Nia Bay. Oh, that's funny. They added some notes within the name. Foul Weather Bluff. I actually was there less than a month ago. And guess what? It's actually really pretty. Golden Gardens is beautiful. Gorst is the absolute gem of the Olympic Peninsula. So cool. This is really fun. This is really neat. Somebody saw this bird on the Seattle Bremerton Ferry. So now when we look up this bird and we click on maybe a locations tab or something, or we can have like an old expandable window, we can just see this huge list of places where this, bird has been seen. And say they want to click on a specific location, we can have it pop up on a map, maybe show some other birds that were there, but we can click on Point Wilson and it will have as a link, location / and then the score right here, this 509262, and we'll find our entry for Point Wilson. So cool. Oh, Cape Flattery. Take a friend to Cape Flattery and then tell them how amazing of a hiker they are. They'll have so much fun. Cape Flattery is beautiful. Maybe I should just create a Washington State tourism app. It has a bunch of Redis applications somehow. I love Washington. I don't know if you can tell. Okay, cool. Let me just wrap this up by creating the same kind of return that we did for our locations. So here, how do we return it? Oh, sorry. Switching gears here. So we're returning locality ID and then the bird set. And so now we need to create, get all birds that have been sighted at a location, search birds, locations, locate. We already did that. So that's this one right here. And then get all locations that have that a bird has been sighted, specific bird. Sighted. Okay. Specific right here, sorry. And so our endpoint will be at app.get, and this will be birds, and this will be the taxon ID / locations, and that will give us a return, a hook for this, async def read bird locations, and this will be the taxon ID. I really like so far Fast API's ability to just take out query path and body parameters, request parameters. Oh, hey, nobody's told me this. Come on now, I'm coding. We don't care about watching the insight anymore. I really like how Fast API allows you to extract query path and request parameters very easily because it's just used to it. It knows exactly what you want because it's kind of building upon previous framework methodologies. So yeah, it's just really nice. And we haven't played with request parameters and body parameters yet, but I've done it in another project, and it's just really nice. We'll play with it later on. Retrieve the sorted set of locations from birds. Birds or bird? Just bird. From bird colon taxon ID colon locations. And this actually is not correct. It's one location, many birds. So one bird, many locations. We'll update that here. Okay. So bird sorted set key equals F bird colon taxon ID locations. And yeah. So I've generated my key that I want to use, and then bird sorted set equals redis.zrange bird sorted set key, and then 0 is my starting cursor, and I want to go the entirety of sorted set, and then true, I want it to be descending, and then true with scores. Or no, false, I don't want it to be descending. I don't even care about this, but I just have to add it. Okay. This up a little bit. As a sanity, or as a verification that everything's running, length of the sorted set, so len bird sorted set. And should be good. And then I'm going to return just this quick little object here. I always like to, as a kindness, return the taxon ID. Like, this is what you searched for. This is what you're getting. And then locations set is going to be, well, it's actually really a list. So I'm going to do this. I'll change this to list. As the front end's really going to never know. They're not going to know. They don't care if this is a list or a set, honestly. So locations list is going to be well, I'm not happy about that naming. I might change that. Locate birds list locations. Wow, what have I done? That's weird. Okay, whatever. Okay. This should work. Let's take, I'm going to go back here, find the bird that we created. Oh, you know what else I forgot to do? I forgot to iterate through every single bird and do this. But you've seen this done before, so I don't really need to do it again for you. You just trust that I'll do it. So let me Oh no, did I call this again? No. Being obstinate. All right, here's my curl. So let me do a bird colon this colon locations. And this, I do believe, will look up. Oh, holy smokes. Did you see that? That is awesome. That's how fast it should be. So here again is a list of all of our locations with the names. Let me copy this into our browser. Let's switch all of us to the browser. And then, wow, that's fast. Wow, that was fast. Okay, this is why I like Fast API. And sure enough, here we go. Here's a list of all of our locations where we've seen this one bird, or well, this one species of bird, not one single bird. And then this, well, this is unfortunate, but this is just how it is. This is the ID minus the L in the beginning of it. So yeah, that's actually exactly how I wanted it. This is what I wanted. So I'll clear this up. I will do this for every single location. I believe it's time for me to push this up to GitHub in case anybody wants to keep score at home. And yeah, I think that's a good stopping point because that was a pretty major thing. It was kind of chunky, kind of funky, like peanut butter, but we actually got it done. So that was nice. Cool. Well, thank you very much for stopping by and checking out this stream. Next week, I'm going to be traveling, so I'll try to set up a stream, but I can't guarantee everything. But if not, you can always reach me on Discord and I can kind of share with you what I've been working on. I'll be flying for 6 hours. I'm going to Maine. So I'm going to be playing with this a little bit while I'm up in the air flying. So maybe I'll share with everybody on Discord what's going on. But yeah, thank you very much for joining me. Thank you for letting me indulge in the birds of Washington State. As always, I am a avid bird fan, as you can probably tell. And it's a lot of fun, kind of utilizing, today's theme was like utilizing Redis to its highest ability to deliver data quickly to the user. I know that storing, retrieving, and indexing and searching JSON has been on the tip of my tongue for the last year, but sometimes simpler solutions are very fast solutions. So as you saw, looking up one bird and getting all the locations is extremely fast. And that's what is so great about Redis. Every day as an employee, I learn something new about them being Redis. And different, ways of just storing and retrieving data. It's very fast, and space is kind of cheap when you have small data sets like this. So that's really cool. I have increased a lot of keys within my database, and I increased it by 1 meg. So that's pretty ridiculous. All right, everybody, have a wonderful Monday, and I'll see you later. Take it easy.